this is what happens when we try to hammer a nail into the substances. And we know that the metals are bendable and malleable, and that's because the atoms can just move around and the electrons can follow because they're distributed all over the place. When we try to hammer something like a diamond, we find that it's actually really hard and rigid and difficult to break, and that's because these electrons are really holding all the atoms together in a very rigid framework. The molecular covalent solids tend to be very soft, and you see the hammer there, the nail just going right through and pushing the molecules apart. In fact, that's why I can walk through the room. I'm just pushing the air molecules apart. I can put my finger right into water. I can put my whole body into water, and all I'm doing is moving the molecules around me, whereas I can't put myself into something that's really hard, like diamond or sand. Now, sand particles, that's a whole other story, but a big block of sand, there's no way that I could, that would be very difficult to break. And then finally, when you try to hammer an ionic material, you see that it just really fractures along a given line. And so we're trying to build this kind of thinking with the students in terms of describing macroscopic properties using these pictures of what the atoms and the electrons are doing.
I have a couple questions from the audience if you have a second.
Sure.
Okay. One question is, do you get into the specific van der Waals forces for the molecular covalent, aka H bonding, sorry, I'm butchering the pronunciation, dipole, yes?
Yes. So let me just explain that one thing that we have tried to do carefully is not to overload all at once. And so the answer to the question is yes. But where this lesson is going to go is this lesson is going to take us into moving electrons around. We've already developed the idea of ions and ion charges. And this whole unit, this alchemy unit, is actually going to end by electroplating and then removing the metal that you've plated. So we're going to learn a little bit about the ionic bond. The whole next unit, smells, is on molecules first. It's on the structure. We call it 8 is enough, Lewis dot structures, shapes of molecules, and then absolutely we talk about intermolecular attractions because that's why we're smelling things. Molecules get in our nose, they attach to receptor sites. So we talk about dipole-dipole interactions and hydrogen bonding at that point and van der Waals interactions. It's just that we really try to sequence it in a way that students could digest the information one at a time. And there was another question?
Yes, there's one more question. It was on the last slide. The user said, this is a new graphic. I like it. On the last one, though, I think it would be helpful to show the cations and anions shifting next to each other, which makes ionic compounds brittle.
I almost said that. So, and I have some nice animations of that. So one of the things that's happening for the rest of you on the line is that you're shifting one layer relative to the other, such that you no longer have a plus-minus interaction, but you have minus-minus and plus-plus, and the whole thing literally just blows apart. And we could draw that a little bit better. I see that. That's a good suggestion.
I think we should take a moment now, before we have about 15 minutes left. I would like to actually show everybody who has been participating today, like, what are your resources that would help you to teach lessons like this, and what is in the second edition package. So are there any other questions before we do a quick tour? Anyone else, Julie?
None yet.
Okay, so let me just give me a second to open it up. What I did for you is you're going to get a sneak preview. What we did for those of you who might be familiar with Living by Chemistry, the first edition curriculum was a complete curriculum where the teacher materials were broken up by unit. And what we did is we wanted to work towards simplifying the package. So we've created what looks more like a traditional teacher wraparound edition for each lesson. But before I show you the features of the wrap, what I wanted to just point out is if I zoom in, and people can let me know, you're looking right now at a zoom in of the student textbook. and what students will see after they've gone to class. And so I want to just point out to you that every lesson in Living by Chemistry in the student textbook directly relates to what they did in class. So this is different than traditional textbooks, which are often more of an encyclopedia of information that may or may not relate to the really engaging in-class lesson that you might have taught yourself or that you might have used from a curriculum like this. So students don't read this textbook the night before in preparation for a lecture. They actually read their textbook afterwards to review and reflect on what they learned. And what you'll notice is that when they're reading their textbook, they're seeing images, as you can see over here on the right. This chem catalyst image is appearing for them again. They're seeing the actual experiment talked about again for testing substances based on dissolving and conductivity. They are, again, looking at tables that classify substances into different groups. There are example problems and practice problems for students. So no matter what was taught that day, whether it be stoichiometry or gas laws or thermodynamics, and no matter how it was taught in class, whether it was a lab, a hands-on activity with some maybe cards or manipulatives, or perhaps it was just a worksheet, the students go home and reflect on that experience. You can see, if you continue through into the next lesson on types of bonding, that these images that were on their worksheets with the models of bonding and what's happening to the substances in terms of properties based on bonding is all reflected in the student textbook. And this was the image, I think, Angie, that you were mentioning about what happens when the substances are dissolved. And we're focusing in for students, as Dr. Stacy said, on what's happening at the atomic scale, what's happening at the scale of particles, and how is that related to what students are observing macroscopically, like in the laboratory or in the world around them. And again, every lesson ends with practice problems. One of the things I wanted to just quickly point out to you, for second edition, one of the things that we added in that was new, and this is at the end of the unit. For the end of the unit, we've expanded our unit review. We now have general review exercises, which are short answer or problems that would require work solutions. And we've also added an additional multiple choice standardized test prep so that there's an additional layer of assessment for students before the end of a unit. So that gives you a little sense of what happens when students go home and use the textbook. And now, for those of you that are familiar with the teacher guide, do not despair. Everything that was included in your teacher guides is now in the teacher edition, or it's a part of the teacher resource package. So you're not losing anything. If you have first edition and you're familiar with that, all of the great resources that you've had before are still available to you. They're just going to look different, and they're in a different form. And in addition to that, you'll get even more because we've added to this teacher edition some smaller features. One of them is called Differentiate, where we actually point out further ways to differentiate the lessons. All the lessons in Living by Chemistry were designed with differentiated instruction in mind, in the way that using guided inquiry and having students do hands-on experiences, having them look at models, write about what they see, talk about things in groups. All of these are helpful teaching methodologies for helping more students understand. All of that is still here and all that is still available, but you'll see now that it's all built into the teacher wrap. So this particular lab, the key ideas give you a sense of what's going to happen, in tomorrow's class. The lab is described here. You'll see, if you notice, throughout the teacher edition, we have what's called the teacher materials button. And this particular button lets you know that there's a downloadable item that goes with this. So, for example, there's a downloadable material. There's a transparency of this particular chem catalyst that you can show on the board. There's a PowerPoint presentation that goes with it. All of these items, just to give you an example of Lesson 25, you have a materials list that you can download. You have a student worksheet, which, of course, you could send to your students or you can print out and have students work on during the class. For teachers, don't give this one out. This is the student worksheet with the answers included for you. So you can have something to use if you're going to be, if students are asking you about questions during their activity, or if you're going to be checking things after they've turned it in. We also have, and I wanted to point out here, a PowerPoint. Oops, that's the wrong PowerPoint. A PowerPoint for every lesson. So every lesson of Living by Chemistry, you can quickly look at this one. We've put in the information where if there was a chem catalyst question, you can display it. Things for preparation, it would be here. We've put the key points and the discussion points, and we wrap up and give the check-in questions. So that's another way to display that information for students if you would rather do that. You can also, whenever there's an image, we provide something that you can make a transparency so that even if you were using an overhead projector, you could use it, or you could print it and hand it out to students. So these are some examples of the resources that you'll find.